Hello students, today we start a new chapter and a module number 2, Theodolite Traverse in a surveying subject, semester 4, subject code is at 3140601. So in a surveying we discuss about the angles and measurement. So far we have been measure the horizontal angle by using the compass. So generally with the help of the compass we measure the horizontal angle with respect to north direction, and it is not possible to measure the vertical angle by using the compass. So compass is only rotate in a horizontal direction only, in a clockwise or anti-clockwise direction only, not a move in a vertical direction. So here for measuring the vertical angles, theodolite is compulsory required. So when the object are considerable distance at a suitable and a considerable elevation or depression, it becomes necessary to measure the horizontal and vertical angle more precisely. So there are the instrument which is used to measure the horizontal as well as vertical angle in a positive and negative direction. Positive means in upper side and negative means from the downward direction. We measure the vertical angle is known as a instrument is known as a theodolite. So in a theodolite survey, some of the instruction is here given introduction about the theodolite. So the system of the surveying in which the angle are measured with the help of the theodolite is called a theodolite traverse. So here you all of you know about the traverse. So traverse is a one type of the joining the line between the each other and different points, and there are the two types of the traverse: open traverse and closed traverse. So if the starting point and end point are meet with each other, like start at here, then after 1 2 3 4 5, so all the points are joined with each other and draw the line, so it's called a theodolite uh, traverse, and this surveying is called a theodolite surveying. So here in a theodolite, the theodolite is the most accurate surveying instrument mainly used for the measuring the horizontal and vertical angle. So here horizontally we rotate the theodolite in a clockwise and anti-clockwise direction, and in a vertical direction we rotate the theodolite in a 360 degree in a vertical as well as in a horizontal. In a vertical direction we measure the vertical angle in a upward and downward direction as a in the form of the positive and negative. And second is a locating points on a line. So if the numbers of the point are required to done in a straight line, so here compulsory from the theodolite ranging is be easily done. And third is a prolonging the survey line. If the 2 points or a 3 points are in a same line and this line is extend up to some of the distance, so from the with reference to these 2 points, we prolong the line or extend the line and select the another point and fix the ranging node and prepare the straight line or prolong the survey line. And next is finding the difference of level. So what is difference of level? So all the points are not at a same level. So from the theodolite we measure the vertical distance by using the staff, and by using the theodolite we measure the horizontal or a vertical distance. So these are the difference of the level. And next is a ranging curve. So in a curve module number, I think module number 4 is there in a serving subject. So in this curve, so in a horizontal curve and as well as in a vertical curve, we prepare in a road network. Clear? So horizontal curve like a turning in a highway or road networks. So we prepare by using the theodolite, and we use this theodolite in a two theodolite uh, method. for a curve, to prepare a curve. And next is the tachometric survey. So tachometry is generally used for the leveling purpose. So in this survey we also use the theodolite. Now next is a classification of the theodolite. So generally theodolite may be classified in the two part. First one is based on the movement of the telescope, like on a horizontal axis in a vertical plane, and based on the arrangement of the measurement and angle. So these are the main classification, and another sub classification are there. So based on the movement of the telescope on a horizontal axis in a vertical plane, there are divided into two parts. First one is a transit theodolite and the second one is a non-transit theodolite. In next slide we discuss about on it what is transit theodolite and what is non-transit theodolite, and based on arrangement to measure an angle. So vernier theodolite and micrometer theodolite. So there are the two type of the theodolite is generally used as per the measure to an angles. So next we discuss about the classification of the theodolite based on movement of the telescope on a horizontal axis in a vertical plane. So in a vertical plane, transit theodolite. So what is transit theodolite? A theodolite is called a transit theodolite when its a telescope can be transited or revolved through the complete revolution about its horizontal axis in a vertical plane is known as a uh, transit theodolite. Means here theodolite telescope is rotated 360 degree. So it's a transit theodolite and non-transit type theodolite. So the telescope cannot be transited. The telescope cannot be revolved around the horizontal axis in a vertical plane completely. So it's a non-transit type theodolite. And classification, second type of the classification is divided into two type based on arrangement of measurement of an angle. So first one is a vernier theodolite and second one is a micrometer theodolite. So for reading the graduate circle, if the vernier are used, the theodolite is known as a vernier theodolite. So here for getting the reading and angles are marked on a theodolite, so it's a vernier theodolite. And where is, if the micrometer is provided to read the graduate circle for the same is known as a micrometer theodolite. So generally vernier theodolite is generally used, and in also in our college vernier theodolite is there. Now next is in a G2 examination this type of the question is asked in 7 marks or in 4 marks. So write the difference between the transit theodolite and non-transit theodolite. So telescope can be rotated about the horizontal axis in a vertical plane through 180 degree. So is known as a transit theodolite. And what is non-transit theodolite? So telescope can be rotated about the vertical axis in a vertical frame through the same some limited angle is known as a non-transit theodolite. So here in a transit theodolite, totally telescope is rotated in a 180 degree, and the position of the theodolite can be changed from phase left to phase right. So what is phase left to phase right? If the vertical disc is left side of the telescope is known as a phase left position of the theodolite, and if the vertical disc is the right side of the theodolite is known as a position right or a phase right. And the position of the theodolite can be changed, cannot be changed from phase left to phase right. So it's a non-transit theodolite because telescope cannot be rotated in a vertical direction in a horizontal axis, and ranging of the line can be done by the backside because here telescope is rotated, so we easily bisect the backside area. And ranging line cannot be done by backside because telescope is not rotated in a vertically 360 degree or 180 degree. And next is a transit theodolite. So deflection of an angle is measured easily, and in a non-transit theodolite, deflection of angle cannot be measured easily. And next is there are the theodolite widely used in a surveying, and this type of the theodolite, non-transit theodolite, is not generally is in a use. So these are the main disadvantages of the non-transit theodolite. Now next is the size of the theodolite. A theodolite is designated by the diameter of the graduated circle on a lower plate. So the generally common size of the diameter of the circle of the graduated circle of the lower plate is common size 8 centimeter to 12 centimeter, and while 40 centimeter to 25 centimeter instrument are used for the triangulation work. So in our college 12 centimeter diameter theodolite is there. So greater accuracy is achieved with the larger theodolite, as they are bigger graduated circle with a larger division. Has we use the survey work require high degree of the accuracy. So if the graduated circle is larger, so accuracy is higher. So if the because in a graduated circle, if the circle is large, so division of the vertical angles or a horizontal angles division mark easily, and we seen easily, and accuracy is increased. Now next is use of the theodolite. So this type of the question is asked in a G2 examination in 3 marks, like what is theodolite, or type, and list the type of the theodolite, and write the uses of the theodolite. So theodolite is used to measure the horizontal angle as well as vertical angle, and to decide true north by astronomical method, and to know the difference in elevation of the 2 points. So it's measured by the vertical distance, and to measure the height or depth. So in by using the theodolite, we use the mathematical step like sin theta, cos theta, and tan theta. We measure the height or depth of the particular area, and to measure the distance between the 2 point, and to measure the slope, and measure the deflection angle between the two lines. So it's important thing to using of the theodolite. Now next is a transist vernier theodolite. So here parts of the theodolite usually seen that one by one we discuss on it. So here vertical axis, objective, then after telescope, altitude bubble tube, this one, and vertical clamping screw for adjustment, trunnion axis. So trunnion axis is a horizontal axis on which telescope is this telescope is rotate, and eyepiece. So eyepiece is a eye vane from which we easily seen. Then after plate level, so plate level is a horizontal plate is provided on a top of the instrument. So next is the upper plate. Upper plate is there are two plate, upper plate and lower plate. So upper plate and lower plate is rotated with each other in a 360 degree, and vernier AB. So in a vernier AB, two window is provided, window A and window B. So from the window A and B, we easily mark or see the angles. So it's called a vernier A and B. So in a vernier A, we measure the angle from the 0 degree, and in a vernier B we measure the angle from the 180 degree. So it's a main 180 degree difference. Then after inner spindle, so inner spindle and outer spindle is required to rotate the instrument in a horizontal direction. And then after leveling screw, so leveling screw is provided to level the entire theodolite, perfectly leveled or not. If not, so then after we rotate the screw in clockwise and anti-clockwise direction, and then after we fix the level. Then after trill batch. So trill batch is one type of the plate is provided to rotate the foot screw or fix the foot leveling screw in a try batch. And then after travet, so travet is provided the bottom plate of the leveling screw. And next is a tripod head. So tripod stand, one head is provided, and here one at the middle one hole is provided to fix the theodolite, in a tripod stand. And then after tripod legs, so there are the three legs in a tripod stand. So one by one we discuss all these things in a next slide. So transist vernier theodolite. So here vertical axis. So vertical axis pass from the top of the instrument to directly center from the instrument. It's a vertical axis. Then after here two vernier is provided, two windows provided, vernier A and vernier B. And lower plate is graduated with this lower plate is graduated with angles. And here upper clamp is provided. So upper clamp is fixed to two plates, and upper clamp is provided to fix the two plates, and lower clamp is provided to fix the instrument rotation. So here next is transist vernier theodolite. So here axis is given. So this one is a vertical axis and vertical axis. Then after this one is a horizontal axis, and this one is a telescope. So from this telescope, horizontal and vertical axis, both the axes are intersecting at a middle point or a center point of the theodolite. And here two circle is provided. So vertical circle is provided at here, and horizontal circle is provided at here at the bottom. So all the vertical angles measured from the vertical circle, and all the horizontal angle is measured from the bottom of the horizontal circle. So all the vertical angle, when the telescope is at a 0 degree vertically, means in this direction. Clear? So at that time telescope is at a 0 degree, means telescope is perfectly leveled and in a horizontal direction only. And here horizontal angle, we measure this horizontal angle only. Now here transist consists of the following essential part. So here there are the main 14 parts of the theodolite. So first one is a telescope, second one is a vertical circle, third one is a A-frame, fourth one is a leveling head, fifth one is a axis means two spindles, and sixth one is a lower plate, seventh one is a upper plate, and eighth one is a upper and lower clamp screw, ninth one is a lower tube, and 10th is a plumb bob, 11th is a compass, 12 is a shifting head, and 13 is a altitude tube level, and 14 is a clip screw. So one by one we discuss all the parts in the next slide. And here this type of the question is asked in a GTO examination in 7 marks, like analyze the different parts of the theodolite and explain any 2 or 3 in a detail with figure. So we start with the first part is a telescope. So see this figure. In this figure you exactly see this portion is a telescope. So it's essential part of the telescope are eyepiece and diaphragm with crosshair and the object lens arranged to focus the telescope. So here in a telescope lens is provided, and when we rotate the focusing screw we adjust the clarity, and also if the distance is large, so we exactly clear the picture of any object, and we fix the target of any points. And next is a vertical circle. So here this vertical circle is provided. So circle plate are supported on a horizontal axis of the instrument between the A frame. So this one is a A frame in alphabet A. So see this A, and vertical circle graduated from 0 to 90 degree in a 4 quadrant. So in a vertical disc is a 4 quadrant, 0 to 90 as a 4 quadrant, so total 360 is there. And a vertical circle move with the telescope when it rotate in a vertical plane only. Now next third part is a A-frame. So two stand resembling letter A mounted on a upper plate. So this one is a upper plate, and A is mounted on a upper plate, and Trunnion axis of the telescope is supported to A frame. So Trunnion axis pass from the vertically from the theodolite and support the A frame. Now from in a next lecture we start from the fourth number leveling head, and these parts we discuss in a next lecture. Thank you.